Hello students, now welcome to the second part of my lesson for introducing logarithms to you. You probably have seen, or I would actually advise you to see, the concept behind logarithm. So a quick sneak peek on that. When you have something like log 25 base 5, it's like asking a question, 5 to the power of what is 25? It's just like asking 5 to the power of what is 25? And of course your answer will be 2, isn't it? Which means that 5 squared is 25. So logarithm actually evaluates to the exponent. So what is a logarithm? Logarithm gives exponent. So x is the exponent here, and a here is called the argument, and b is the base. B is the base, right? So the same thing can be actually written in the exponential form. So the logarithmic form is log base b of a equals x, fine, but how would you write the same thing as in an exponential form? You would say, like with the same thing, b to the power of what is a? So b to the power of what is a? That's the question. And that what is this x, correct? So we would write x here. So in other words, the same thing in exponent form would be b to the x equal to a. All right. So, so we are going to convert between forms here. So just before that, we need a small information that if you don't see a logs with a base, if you don't see a base, then the default base is 10. So this could as well be written as log x. And if you don't write a base, it means the default base is 10. And those kind of logarithms are called common logs. Okay. So common logs do not have a base, or I should say they do have a base, but we don't have to write it per se explicitly. So now let's go ahead and convert between logarithmic form and exponential form. So we have here log base 7 of 49 is 2. So how would we write this in exponential form? So again, ask yourself the same question. 7 to the power of what is 49? That what is 2 here. So 7 squared is 49. Okay, so the exponent, the answer here, which is the right side, is actually the exponent when you write in the exponential form. Okay, so likewise, 2 to the power of what is 32? 2 to the power of 5 is 32. Now here you see there is no base, meaning the default base is 10. So 10 to the power of what is 1000? 10 to the power of 3 is 1000. Right? You just go ahead. It's just like the same thing. Even though you have fractions, or the argument might be a fraction, or the exponent might be a fraction, doesn't matter. It's still the same concept. 4 is the base. Base is always the base. 4 to the power of what is 1/64. 4 to the power of negative 3 is 1/64. And so on and so forth. I will leave these to you to write down the exponential form. Now what if logarithmic form is given and you have to convert it to exponential form? It's still the same thing. Exponent is the answer for the logarithmic form. So this 2 here, this exponent will come as equal to 2 on the right side. And 5 is always the base. So log base 5. 5 to the power of what is 25 is the question. So the argument becomes 25. So 5 to the power of what is 25? It is 2. So that's how you write it. Likewise, now 0 is the exponent. So this time when you write in the logarithmic form, the 0 should be on the right side of the equation. That's the result of the log expression, which is 8 to the power of what is 1, correct? So log, when you write it, the base is always the base here. 8 to the power of what is 1? The 1 is the argument here, right? So log 1 base 8 is 0. And that's how you go. You just have to play it through. So negative 4 is the exponent. It comes here. Base is 3. So 3 to the power of what is 1 over 81. So this, it's better to write them in parentheses, the arguments. Log base 3 of 1 over 81 is negative 4. Okay. So that's how this goes. So right? So that's how this goes. So I'll leave the rest to you. And now if you actually have to evaluate logarithms, it becomes much easier because now you know the concept of logs. Logs are evaluating to the exponents. So the question here is 6 to the power of what is 36? In other words, you're rephrasing it. 6 to the power of what is 36? It is 2. 6 squared is 36, so 2 is the answer. Likewise, 2 to the power of what is 128? And if you actually see, 2 to the 5 is 32, 2 to the 6 is 64, and 2 to the 7 is 128. So the answer here is 7. Okay? And so on and so forth. If you see 16th question here, 16 to the power of what is 2? So let's call that what as x, for example. And we know that 16 is 2 to the 4, right? So 2 to the 4 to the power of x is 2. I mean, this is one way of doing it, right? We know that 16 is 2 to the 4, so it comes to on the other side. It's 1/4 will be the answer. But just to show you, this would come as 2 to the 4x equals 2 to the 1. The bases are same, so equate the exponents. So 4x equals 1. When you solve for x, you'll get 1/4 as the answer. So 1/4 is our answer here. Okay, and so on and so forth. I would like you to try the others. Now there is something called change of base formula. Change of base formula. So normally in the calculator, below TI-83 and below, there may be a situation where you don't have a base, only log function is used. So in those cases, you can conveniently use log A over log B as a change of base formula, provided the bases here are the same and we are conveniently using them as common logs. Okay, so I'll show you. I have this TI calculator, right? So if you look at here, there is a log button here, but there is no base, so it's a common log. It's base 10. But what if you have something like this? All you have to do is go for math and you scroll down, you'll get log base here. Then you can actually enter the base. For example, if you try the 20th question here, you need a 2 and then 98, correct? Then it'll give you the answer. But what if you don't have that feature in your calculator? What you need to do is you just need to do log 98, use the common log, log 98. You can even use the natural log, but I still didn't introduce natural log to you. So you can use this. Log 98, make sure there is a closed parenthesis here, otherwise it will give you a wrong answer. Divided by log 2. And that's the same answer as the above, isn't it? So this is a convenient way of using change of base formula. Okay, so here it is 6.615. Okay, so you can easily find these. I'll move on. Now let's come to natural logarithm. Natural logarithm is based on the number e. It's an exponential constant, and it was actually discovered by this famous gentleman, mathematician Euler. He was well known in the fields of math and physics. So Euler is he has played a significant role, and he actually discovered the value or the significance of e, the exponential constant, which is normally 2.718 and so on. It's just like pi, it's an irrational number, just like pi. Pi is 3.14 and so on, right? Same way, e is also an irrational number. So it is a number, it's not a variable. So it is called, when you use e as the base of a logarithm, it is called a natural logarithm. And in short, we actually write it as ln. So log x base e is same as ln x. And this particular thing is also seen in the calculator right here. If you see my mouse there, that is the ln. So if you have to actually convert this into exponential form, as he's asking here, ln x equal to 4, it actually means log to the base e of x is 4. That's what he's saying. So in other words, now we know how to do this. Because the exponent is 4 and the base is e, we are saying e to the power of what is x, and that what is 4, we know that, that's the exponent. E to the 4 is x, correct? So we can actually find the value of e to the 4, because e being a number, if you do second and ln, you will go to e, and e to the 4 is what we want, and e to the 4 is that number, 54.599. So, or I could write as 54.6, right? Likewise, where was I? Was this the one? No, sorry, 54.6 is here, my bad. So, let's move on to the 26th question. Here he says ln 10, which means log to the base e of 10 is x. So if you have to convert in the exponent form, this would be e to the power of what is 10, and that what is x, e to the x is 10. Okay. Now if we have to convert the opposite way, exponential to logs, the exponent here is x, and that would be on the right side of the equation. So we would say e to the power of what is 50, so it would be log to the base e of 50. So e to the power of x is 50, so you will say log base e to the 50, and log base e is ln, right? So we can write this as well as ln 50 equals x. And you would see what is ln 50 from the calculator, and you will see that it is 3.91, and that's the answer, 3.9. Okay, I will leave this to you, you can handle this. And so even these two, 29 and 30, all you have to do is ln 64, just do ln 64, which is 4.16. That's it, it's as simple as that. So yeah, so this is the thing. I would want to do some questions in Math Excel if needed. But yeah, so this is logarithmic functions, logarithms, how to evaluate logarithms, how to convert between exponential logarithms, what is a logarithm in the first case, all this. Thank you for watching. I'll see you in the next video. Thank you so much.